Shannon will hear you. Say hi, Shannon. She's not there. Maybe she'll watch the video. Everybody say, good morning, Shannon. Oh, they wouldn't do it. I got a lot of emails on Sunday from students saying I was called by the principal and told I have to quarantine for 2 weeks. I must have been too close to somebody based on seating charts. So I think there was a lot of people sent home or told on Sunday they got phone calls told they have to quarantine. I don't know. All right, so binary to let's go decimal to binary first. I'm just going to make up a couple random numbers and give you maybe a way to think about this. So binary, so this is 21 base 10, and binary place values are base 2, meaning each place value is the next power of 2. So it's really 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5, and as numbers, that's 1, 2, 4, 8, 16, 32. We notice that these numbers double, right? Because it's just one more multiple of 2, or sorry, one more factor of 2 in there to make those place values. All right, so here's a way that I think about it. I kind of think, what's the biggest place value that doesn't go over that number that I even have? So like 21 is not as big as 32, so I would not use a 32 to make a 21, right? But in trying to make a 21, I may use a 16, because that's, right, I'll actually need more than 16. So I will actually just think about it this way. Putting a 1 in the place value, so that's going to become the 2 to the 4th of the 16 place value. So think 16, 8, 4, 2, 1. And to make 21, I'm going to grab as much of the 21 as I can with the biggest place value I can, which I can put a 1 in the 16, and that just used up 16 of the 21 units, leaving 5 left to go get. I need to, right, represent a total of 21. So I've got 16 right there. The next place value is an 8. Well, I'm only trying to represent 5 more, so I don't need an 8. That's too big. Here's a 4. Yeah, I can use a 4 to make a 5, so I need 1 4. And now I just need a 1. Well, that's a 2. Nope, that's too many, and a 1. So that's me kind of thinking through how to make 21 is 1 0 1 0 1. Does that make sense? As a way to think about it? I know that's not what they showed. I showed, and they show successive division, but I think with small numbers, this is just an easy way to think about it. So, what if we had 7 base 10, right? Well, I'm not going to use the 8 place value because that's too big, right? So I just need the 4s, the 2s, the 1s. So if I use a 4, I still got to represent 3 more to get to 7. That's a 4. So, well, I need 3 more. That's only a 2, and that's a 1. So I'm going to put a 2 there, right? So that's 6, and then I need that 7. I don't know. Successive division would look like this. So I'm giving you 2 ways to think about it. You take the number, and you divide it by 2. On the screen, yeah. And what we're really interested in is finding out kind of what the quotient is and if there's a remainder. So 2 goes into 21 how many times? 10. 2 times 10 is 20. You subtract, we'd get a remainder of 1. Okay? So our quotient is kind of 10 remainder 1. The quotient is going to become the next dividend, and we're going to repeat the process all the way until we have a dividend of 1. So 2 goes into 10 how many times? 5. Goes in perfectly, right? So you have a remainder 0. The 5 is going to go into the next problem. So 2 divided by 5. How many times does 2 go into 5? 2. Right? That's going to give a remainder of 1, though, right? So that 2 is going to get divided by 2. 2 goes into 2 one time. Perfectly, no remainder. And then I didn't leave myself enough space. I'm writing too big. That 1, we're going to keep going until we have 1 as the dividend. And 2 does not go into 1, so that's 0 times. But that leaves a remainder of 1, right? All right. This is your binary value in reverse order. So this is the most significant binary digit, the last one. The first one is the least significant binary digit. So that means this is the 2 to the 0 place value, this is 2 to the 1, that's 2 to the 2, etc. So you're going to take this one and write it first. So it's, right? I think we're kind of doing this. 1, then the 0, then that 1, then that 0, and then that 1. Is that okay? Does that make sense? That's the process. Going back from binary to decimal notation, let's just say I have 1, 0, 0, 1, 0, 1. I just make something up. This is like weighted multiplication, although I don't really need to, multiplication, multiplying by 1 or 0 is super easy, right? I really just need to add the value of the place value if there's a 1 and ignore it if it's a 0, right? I have none of those. So, right, 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5. All right, so like 2 to the 0, and I'll put the values underneath, that's helpful. Right? I have a 1 there. That means I have a 1. 1 times 1 is 1. I'm technically multiplying these numbers in those two rows. So I've got a digit of 1. The place value that it's in is worth 1, so 1 times 1 is 1. In the 2's place value, I don't have anything. So I have 0 2's. 0 times 2 is 0. I have 1 in the 4's place, so I have 1 4, or 1 times 4, which is 4. All right? I'm going to add all those up, and it gives me my decimal number. But 0 times a number is 0, so I'm really just looking for the 1's and what place value. So here I have 132. 1 times 32 is 32, and that's it. I have a 32, I have a 4, and I have a 1. So we get 37. Does that make sense? All right. So I'll leave this recording for a second. Not very long. I'm going to hit pause, or I'm going to let they can hit pause and look at the video screen. So I don't have a super long recording. Let's just kind of put that there for a second. People that were checking this from home, they would need to hit pause now if they want to look at it up close. Right? Pause. And then, if you want to check, when you're ready to check the next page, there's that.